Doing good, ma.
When did you reach?
Yesterday.
Oh, okay. So you have
Good
taken
evening,
rest?
Of course. Sure.
Okay.
Yesterday full. Yeah.
Speaker has arrived.
Yes.
Hello, ma'am. Good evening.
Yeah, good evening. Mr.
Very good
Shashwat.
evening.
Good evening, Dr. Shanmugakumar.
Good evening, sir.
Good evening.
Hello, sir. So when people are joined, we are ready to go.
Another 5 minutes.
Sure, sir. Yeah. We'll take that.
So YouTube live streaming started, sir.
Okay. Okay, we'll start now. Good evening and greetings to one and all. On behalf of the organizing units, IEEE Computer Society, CSI, and ACM, I would like to extend a warm welcome to our today's speaker, Dr. Shanmugakumar Murugesan, the members and my colleagues from the organizing units, participants who have joined the meeting through Google Meet meeting link, and those watching the webinar through YouTube streaming. With the growing population, there is a greater stress on food security globally. United Nations has also emphasized on sustainable farming to meet its first goal, which is focusing on eliminating hunger. While several technologies such as IoT, drones, robotics play a vital role in agriculture, collectively known as precision agriculture, in different parts of the world, India is trying to catch up in this area to be more competitive. The focus of today's event is on adoption and future directions of technology in Indian agriculture. The speaker intends to cover end-to-end of the agriculture practices and application of technologies at every stage in the agriculture cycle. In this presentation, the speaker will delve into dynamic landscape of Indian agriculture, focusing on the crucial aspects of technology adoption and future directions. India's agriculture sector is undergoing a significant transformation, driven by technological advancements and the need to meet the demands of the growing population. The presentation will explore the challenges and opportunities in several key areas like pre-harvest, post-harvest, yield prediction, pest and diseases control, highlight innovative solutions and technologies that can optimize pre-harvest processes such as precision agriculture and sustainable farming practices. Examine the critical post-harvest issues, including storage, transportation, and minimizing food loss and waste. Present cutting-edge methods for disease and pest detection, prevention and control, including the use of data analytics and biosecurity measures, and introduce advanced techniques like remote sensing, artificial intelligence, and data-driven model for more precise yield forecasting. I am sure that today's presentation will provide a lot of learning on the subject which we normally take granted. Now let me have the pleasure of introducing the speaker. I had met Dr. Shanmugakumar first time at Tech University at a conference about a year back. While his approach to the topic was innovative, we got connected through LinkedIn and exchanged messages in order to organize this presentation today. Dr. Shanmugakumar Murugesan is a co-founder of deep agri-tech startup named Matic, which is expanded as Modern Agriculture Technology Innovation Center, having a vision of shaping the agriculture and reshaping the nation. Matic aims to simplify agriculture practices with advanced technologies to reduce wastage, improve quality and productivity. The focus is on developing affordable technology for Indian farmers. Dr. Shanmugakumar has completed his bachelor's in Electronics and Communication Engineering from Anna University and Master of Design in the Department of Electronics and PhD from Department of Computer Science from IIT DM and M at Kanjipuram. He also teaches at Shiv Nadar University as an adjunct faculty to enlighten young minds for better India. With this brief welcome note and introduction of the theme and the speaker, let me invite Dr. Shanmugakumar to take over and enlighten us on technologies in sustainable agriculture. Over to Dr. Shanmugakumar, please.
Thank you, sir. Thank you for the introduction, and I warm welcome everyone in the evening. I hope I'll try to make you engaged. Okay, I just like share what are the experience that we have came across and are learning. I'll put it, and we'll get in. Okay, so before getting into the topic, I just want to make sure certain things are certain facts, right? So everyone knows the world population is increasing. Yeah. If the world population increases, what we need a more food.
Would you like to present your slides? Just
Yes.
open it.
Can you able to see my screen?
Yes.
Yeah. Okay. So, as I said, world population increases, we need more food. If you need more food, we need to do more agriculture. If you need to do more agriculture, we need more people. But what exactly happens in the reality The number of people who do agriculture is reducing. The population is increasing. So this is basically giving a gap on the food security. Point number one. The biggest challenge that what entire world is facing today is a climate change. So, like, of course, everyone aware of this. So climate change, the first thing which is affecting out of the climate change is agriculture, at least in the perspective of human being, right? So agriculture is very hardly affecting because of climate change. Why? Because agriculture need a proper climate. It's all seasonal, right? So we take a mango very recently because we closely work with mango. So I'm just giving an example with mango. Last 2-3 seasons, the flowering was very good, but the seasonal shift has made a drastic production loss in the mango industry. Simple. Why? Generally, mango is season fruit. Exactly at the December, flowering starts. Somewhere at the beginning of February, the small fruits comes. And exactly at the time of Shivratri, okay, probably would have noticed it this year. Okay, what happened? Post Shivratri, 10 whole days, it was like heavy mist was there. What happened? This mist directly affected the production. Why? This heat should be there to convert that fruit to, the flower to fruit, but it was not there. Just the 10 days extend in that mist, means the snow, whatever we call it, that has reduced almost 30% of the mango production. See, can you imagine how the climate change is affecting the fruit production, especially in the mango, right? The same scenario applicable for any agriculture producers, okay? So now, what we are going to discuss in the next 1 hour is like, what are the challenges that we are facing today, right? So how can we solve these challenges with the help of technology? See, ultimately agriculture, when maybe some 50 years back, when we speak about agriculture, the agriculture and the technology are something two different entity, but today it's not. Why? Because technological solutions are need of the hour for agriculture today, especially in India. Why especially in India? If you ask me, that is the most crucial part. So what happened in Indian agriculture system? Okay, almost 50% of the Indian population is rely on agriculture. Okay, we give pretty good contribution to Indian GDP, but what's the problem here? The one who's underlying the working, the farmers, right? So they are owning just only 2.5 acre. What's the problem? They're just owning very small amount of land because their revenue is very low. Because of their revenue is very low, they are facing a lot of challenges to adopt technology in the agriculture. See, look at, we need technology in agriculture to produce more, but the farmers are not ready to take technology because they couldn't afford it. So now this is the biggest challenge in terms of business. Okay, so being a startup fellow, okay, I'm just like putting these things in the perspective of business too. Okay, so now how can we solve this problem? Okay, so how can we give a cheapest technology to the farmer? It's not possible. We cannot develop technology for so at cheap cost, right? Okay, but because it has its own cost, we cannot go down to it. We need more production. So somewhere we should have a better model, a better technological based solution. We can able to solve this problem. Okay, so just keep this in mind. Okay, so in this perspective, I'm going to take you till the end part. Okay, so now what we do, what is agriculture basically, and how can we split this agriculture into 3 categories, like, pre-harvest, harvest, and the post-harvest. Basically, what we call this as like, farm to fork, like somewhere like you start from the soil and it comes to your plate for eating, right? So the whole journey of the food, what are the challenges it has undergone, what are the transformation it has gone. Okay, you take any commodity, means, okay, we discuss about that, and each and every stage, what are the challenges it is there, and with technology, and how can we solve this, and is there any proven technology people have converted this into a big business. Okay, so that's what we're gonna discuss in the whole thing, and we're gonna discuss about something in the future. Okay, so like at the last we discuss about 3D printed foods, we discuss about plant-based meat, we discuss about tissue cultured meats, and so on, right? So because that's also adding value in the agriculture, right? It's beyond from the farm, but still you can able to eat something, right? So put all together, we're going to cover it. Okay, so let's get in. So if you ask me, okay, let's take a mango, because I'm very close to mango, and mangoes are national fruit, so that's the reason I'm taking mango, right? So take a mango. Mango, it's coming to your table. Before it coming to your table, it has undergone a lot of process. So somewhere are grown in the farm, So mango has been grown very well in the farm. It has been harvested, came to a collection center, and it has been transported to the processing plant. They properly pack it, then they give to a distribution center. Then it comes to your market. You go, you buy it from the market, then you eat it. Right? So any commodity has this 6-7 steps in very common. Right? Okay. Take rice or any agriculture commodity, fruits, vegetables, fish, like whatever you take it. It's very common. Okay. So how this agriculture has been transformed from the olden days. Right? So we know, we call it a civilization. The first identity of being a civilization is like, growing food by ourselves and save food for ourselves. So that's the basic reason for the human civilization, right? Okay, because that's where we started saving food for ourselves. And in fact, if you see it, none of the animals save food, okay, except human being, right? So agriculture is one of the key civilization parameter, right? And it gives us a lot of leverage, and because of that we have a lot of free mind to think of betterment. So that's how the human evolution comes. I believe in that. Okay, so what happened, we started cultivating wild spices. Slowly we adopted in our cases, and then we started adopting wild animals. They convert into domestic animals. Okay, like wolves become dog, like cows and so on. And if you look at the history, somewhere lakhs of years before we started collecting grains from the wilds, 11,500 years before we started planting, means like that's what the civilization near to the. In fact, even if you look at the civilization, it's always near to the water available area, because we need water for food. Again, we need a water to grow it, agriculture, right? And we domesticated animal, and this agriculture practice has been keep on evolving. So each and every generation of the people, they're adding a feature to it, like how to make it better. Okay, multi-cropping techniques. See, people are doing multi-cropping since thousands of years, it seems. Okay, I was very surprised to read that when I was reading the document. So this happens, and now what happened very recently, because of very high drastic population increment in the globe, what happened? So we started going a bit more deeper, like a god level. We started changing the genetics of the plants to get better yield, right? So and then we come up with a better and efficient techniques to get better crop, because when we go better crop, what we get? A better yield. When you get a better yield, we get a better food. So this happens basically. So this was the major success parameter what we have carried till today, right? And as a result, we got very good in production. So we are always producing as like what there's a demand. So there's always the production and the demand has been properly met. So till today, yes, this keep on happening, but some season, like last 1 or some 3 months back, the cost of tomato has been very super rocketed. It's why? Because the production and the demand gap was big, right? So okay, so yeah, that we discuss in the later, right? So put all together, agriculture is evolving, but today, as we discussed, the climate change is highly affecting, and the climate change is affecting only the plant. No, it's giving leverage to new pesticides. Okay, so it's basically trying to shake the entire agriculture, right? And in the perspective of small scale farmer, it's very difficult for them to adopt high tech to solve this problem. Okay, fine. So as I said, okay, we're going to discuss the whole story. That's just a brief intro about the conversation that what we're going to have it today. As I said, the term, the farm to fork. Okay, so the term farm is like somewhere where the food is getting started. The fork is where it's getting consumed. So what I'm going to do, I'm going to split this into 3 different categories. Okay, in some cases, I cannot give very general explanation. So I just took some small crops as an example. So, but the similar thing is applicable for rest all. Okay, or similar, okay, not the same maybe, right? Okay. So look at the pre-harvest. Okay, so pre-harvest is the place where a farmer start preparing the soil. Then he pick a right seed, he plant it, then he give water, then he give nutritions, fertilizers. Let's say a disease has been attacked, then we give better herbicides to it. Let's say some pest has come in, so we give pesticide to it, and then we keep irrigate it, we keep monitor it, and we do weed control, because like the plant, right? So other sub plants will come near to it. Eventually, if you allow them to grow, what happens? All the nutritions of the plant where the crop supposed to take, it will be taken by the weed. So we are not allowed to grow them in the farm. So we take that. So let's assume we made it all. Then one day will come when we decide that, okay, the crop is mature to harvest, right? So this whole journey what the farmer is doing is called the pre-harvest, right? So now the harvest. Okay, so harvest is a 1 day or a 2 day process, but that is very crucial process. See, the pre-harvest can goes for a month. Okay, how equally important the pre-harvest, the harvest also very important. Why? Because that is a place where we convert this into a product or the produce, and this harvest techniques and the harvest stuffs decides how much wastage is going to happen in the future. Okay, so that's the reason I took this harvest as one dedicated part. Okay, and the next is the post-harvest. So post-harvest is what, after harvesting from the farm, how you process it. Let's say, for an example, we'll take a rice, right? So let's say it's harvested from the land. So what we do next? We dry it, okay, and then you put in boiled rice. Okay, we boil that rice, okay, and then we break the grains, and then we boil the paddy, and we break the grains, we get a rice. Correct? And the rice is transported to you to the shop, and then we get it. The whole journey is what I mean, the post-harvest, right? It comes to your plate. So the farm to fork is divided into 3 categories: pre-harvest, harvest, and the post-harvest. Okay. So now let's get big deeper into the pre-harvest. Okay. So as I said, the pre-harvest, first you start with the soil. Okay. So generally, what a practice should supposed to happen, okay, or what generally a practice happens in the Western country, or what we are lacking today, and what we are trying to fill with new set of startups. Okay. The first is the soil preparation. Okay. If I honestly say, okay, 90+% of the people are not even aware of the soil preparation, means the soil testing. Okay, soil preparation is not only the plowing, right? So measure the soil parameters. Okay, so nitrogen, phosphate, potassium, how much micronutrients are there in it. Okay, what kind of soil it is, what kind of crop I supposed to put for that. Is there much of boron, so that I'll pick right crop for that specific thing. Are we doing it? Yes, we are trying to do it. Okay, now we are trying to transform. Okay, now it's the right time for transforming our agriculture with the technology, right? So the moment I say soil preparation, measure a soil pH value, right? Measure all the NPKs, measure the micronutrients, and measure all other elements in the soil. After measuring it, then we have to decide what crop should go for it. Okay, that's a case 1. Okay, that's one more case 2. What generally people does, they measure all the parameters, right? Then they decide, for this soil condition, what crop should I put? Okay, so both can happen. Okay, either I prepare soil for the decided crop, or based on my soil, I pick a crop. Okay, both is actually good, right? But what's happening in India? Both are happening. But what is the challenge especially in the soil testing? Okay, the moment I say soil preparation, the first we start with soil testing. Okay, what is the problem with the soil testing? Generally, okay, let's say you take the soil testing to soil laboratory, it costs you around 10,000 rupees just for 16 parameters. Okay, in the laboratory, and it's very costly for a 2.5 acre own farmer. Why? Because in the average 1 year, what's his revenue? It's just 1.5 lakh to 2 lakh at the max. Correct. Without if you subtract all his work effort and that, he'll get very bare minimum, right? So it's very difficult for him to afford it, right? And even let's say he's ready to afford it, but for him it's accessible is very difficult. Why? It's somewhere in the city. Okay, let's say Chennai, somewhere in pretty good city only the laboratories are there. So it's very difficult for him to come, give, and then collect the samples and go, get the result and go. So that's the reason. Okay, one startup company, okay, from Nashik, what they come up with, the company name called Neoperk. Okay, I'm gonna share about their story sometimes. Okay, Neoperk. And they have proved it. Okay, so what they did, they come up with a new business model, and they developed a very low cost soil testing device. What they did, they go to a nodal center or somewhere let's say VO office or some similar to it. Okay, they come over there, all the farmers will come with their soil samples in one place. They tested it. Now look at the advantage here. Okay, so things come to his own village. 1, 2, these guys, the Neoperk startup fellows, they go to the farm and they do testing in a mass scale. 2, so it's a win-win situation for both. Correct. But initially what are the initial try? What they did, they went to each and every farm, they tested it. But what's the problem here? The operation cost to do this job was become very, very difficult. So they become eventually they couldn't do this for longer time. But when they come up with this nodal point, it really clicked. Now the question is, what are the parameters that they are giving it? And they give basically NPK. See, what I strongly believe, okay, we don't need to go so deeper into all the micronutrients, but the basic level of micronutrients, you fill it, that's good enough. That they are solving it. One. Then they had a very good suggestions to the farmers, says you add like, gypsum to increase your pH value of your farm, or like you add some excess nutrients to it so that you can plan for this. Okay, as we discussed earlier, all the two possible cases they are suggesting it. And who's they're focusing? They're focusing on the FPOs. And what tech they're using? They're using infrared based soil testing stuff. Okay, so let's look at the problems is not solved. Okay, all the agriculture problems not solved by only one company. They just solve only soil testing. But how much farmer they have onboarded till today? Just only 2,320 farmers. And how many farmers are there in our country? Millions of farmers are there. And is it only Neopak can able to solve this problem? No, it's not possible for Neopak actually, if you ask me. So in agriculture, it's not nowhere it's called a competition, it's all a collaboration, right? So one startup, they dedicatedly work on how to develop, how to build a more efficient soil testing tool so that we can able to give this service to all the farmer. Why the challenge all the farmer? Because we own very small number of acre. That's the biggest challenge in India today, right? Okay, good. So that's, let's assume you prepared a soil. Okay, so step number one is done. Now what's the problem now? You have to pick a seed. Okay, what if you pick a bad seed? Even though you prepared your soil well, if the seed is bad, it's not going to give a better yield for you. Correct. So the next critical thing for you is to pick a right seed. Okay. So, but what is the one pretty good trend in India now? This, like, the seeds has become a corporate culture where people have already properly picking the right seed for harvesting. Okay. So this problem has been sorted, but still there's a lot of technological gap to pick a right seed. What happens? Say, let's say you take a paddy, right? So if you want to really get a good paddy, okay, so the oil content, the grain is supposed to be more. Okay, how do you measure the oil content before you break it? So you need a non-invasive technique to measure the oil content in it. So problem number one. So is there any non-invasive technique to pick a right seed so that it will give a better crop, right? So there's a big technological gap sitting over there. Like I just gave only one example as rice, okay? And take in India, India is the world's second largest producer of the agriculture, we are the second largest producer. Take rice, we are very good in production. Take mango, we are in the top. Okay, you take anything. Okay, we'll be very good in production, right? Because the scale that what we do is big. But are we doing it very effectively? We are trying to do now, right? Okay, so picking right seed, the challenge. Okay, what's the challenge here? A non-invasive technique to pick a right seed is a big challenge, right? Look at a seed sowing, right? So before you go for a seed sowing, you're supposed to give a right environment for a seed sowing, right? So the soil temperature is supposed to be very good, and the sowing method and the right way to put it is very important. Okay, that's happening. And the seed sowing is, again, what's the problem in the seed sowing? It's a labor intensive problem. And what's need for this? Okay, how can we solve this problem? Is with the mechanization, right? The more precise mechanization need to go for a seed sowing technique, right? So now there's a huge mechanization gap in the seed sowing. And look at the problem with this agriculture in India. When we think about a mechanization, giving a generalized solution to every crop is very challenging. The biggest challenge, okay, giving a generalized solution is very, very difficult. So it's supposed to be a crop specific solution. When you go for a crop specific solution, making money out of this become a challenge. So that's the reason the adaptation is pretty slow in India, right? But it's happening, but it's pretty slow in phase, but it's steady in phase. I agree, right? Okay. So once you put a seed, what the next job is to irrigate it. Okay. Now the question is, are we giving a right amount of water to the plant? Okay. The answer is we give excess amount of water to the plant. Why? Because we get water for free. Are we having any regulatory mechanism to give right amount of water to the right plant at the right time? Yes. So that is where a company comes with smart irrigation where they measure the climate, okay, whether it's going to be sunny, humid, it's going to be rain, put all the next 24 hours, the climate prediction we take before going for irrigation. 1, 2, we measure the soil moisture level at current instance, right? We take this, okay, the both parameter. And the third parameter is how well your plant is grown. Okay, see, when you go for a smart irrigation, you should start tracking your plant from the day 1. Okay, the day today I sow a seed. Okay, I got the first germination. Again, I started seeing leaves. At the day 1, what it needs is maybe 10 ml of water. Okay, but if you look at after the 30th day, it needs somewhere around 100 ml of water. Correct? And if you look at the day of, like, let's say after 3 months, let's say the 3 months crop which is going to harvest. So maybe before harvest, it may take like per day, it may take somewhere around like 10 liters of water. Correct. So how you decide right amount of giving water to that plant, right? So now this is given by a value called ET value. Okay, I hope you know about ET value. It's called evapotranspiration value. This basically takes a parameter of the soil moisture level, the climatic condition, and the plant growth rate. By combining these 3, I decides how much amount of water should I give to the plant. With a drip irrigation or like, any type of irrigation technique we can take it, right? So giving right amount of water to the plant is a big challenge. And why we really think about water? Because of the climate change, water is also a problem. Sometimes we get so much, sometimes we get nothing. Correct? So somewhere we should really save the water. Okay. On top of it, look at the groundwater level of Indian agriculture base is going down. Okay, which means that eventually someday we will get emptied, like how we think about oil, right? The same thing can happen. So we should be really responsible to give right amount of water and don't waste the water, right? So that need a proper ET value calculation, and that need all the 3 parameters together to give a right amount of water to the plant. Okay, that's on the irrigation. Okay, so let's assume, okay, we prepared a very good soil. We give a best seed to grow. Okay, we properly sowed it, and we give rightly giving a water. Will we get a really good output? No, because see, it's a cumulative parameter, right? So look at now what happened. Because I'm giving very good thing, I start getting a weed. If I allow the weed to grow in the farm, eventually what happened? The weed started taking all the nutrition from the soil. Then the crop is losing the energy. So that should not happen. So somebody should take the weed away. There are 2 techniques to take the weed away. Okay, what is the technique number 1? Weedicide. Okay, so just spray very intense red color coded chemical, you kill them, right? 1. 2, go mechanically, you deweed it. Okay, what's the problem with the mechanical stuff? It's time consuming. What's the problem with the weedicide? It's red coded. Okay, eventually this layer of the chemical sits on the plant, and that eventually come in the fruit, and that we eat it. Okay, that's not really good for our health, right? Okay, and that's not in the actually good agriculture practice list. Okay, so we should not use that. So what is the solution for this? We should come up with a mechanical device where to pick right weed. Okay, we should have to identify the weeds. You should take it away. Okay, are we having such a sophisticated technology to pick only weed from the farm? Yes, people are working on it, but not in India, in the Western country. Okay, so is there any startup who works on this part? Yes, people are working in Hyderabad. Okay, that's one startup. What they do, they are developing a small rover, okay, where it can able to get into the farm. What it does, they basically had a camera. Okay, they basically train with computer vision. It identifies the weeds, and they had what small trick, and it will take it away. So we can able to do it. It's happening, right? So weed control can happen with least labor and without any harmful to the plant and to the environment. Okay, so with the computer vision, people are doing this. And is it possible, and whether that same rover can be adaptable for all the plants? No. Let's take a paddy. Paddy grows in deep water. No? There's always a floating water on the paddy field. So you cannot put the rover inside. So you need to come up with a dedicated model for the paddy. So that's what I said. We cannot come up with very generalized solution in agriculture. Okay, it's very, very rare. Okay, maybe tractor is one generalized solution, but tractor has different attachments to it. Okay, Yes. Okay. Now it's about weed control. Okay. Let's assume we control the weed well. Okay. See, look at soil preparation. The first 5 points we did very well. Now look at if a pest is not in our hand, and the disease is also not in our hand. And these two are the biggest killer. Okay. If you ask me personally, in the entire pre-harvest journey, okay, pest and disease management is what the most difficult. If you ask me why it is very difficult, okay. One, it's highly unpredictable. We don't know when it comes. If it comes, the problem is we don't know how to treat it. Okay, means like, right pesticide. Okay, how to give a right pesticide? Okay, first you need to identify what pest it is there. Okay, as a farmer, am I aware of it? No. Literally, okay, the truth in Indian agriculture system is the majority of the Indian farmers are actually not educated. They're intelligent. Okay, they're really intelligent, but they're not educated. So it's very hard for them to understand what's happening around the research, right? So they could identify right pest. And eventually what happened? The farmer goes to the pesticide shop. He just go and say, like, this is a pest. So what he does, where he'll get a better margin, he give the pesticide to him. So what he does, he comes to the farm, he spray it. And there's a one stat says, if you spray a pesticide to the farm, only 10% of the pesticide is taken to the plant, 90% went to the soil and to the air. Eventually what happened? This causes soil pollution and this causes air pollution. Problem number 1. 2, the person who's spraying the pest is inhaling it. So in order to overcome this problem, we got a drone-based pest spraying, right? And that became a very good trend in India, So a lot of people, they started using it. And look at the advantage of the drone-based pest. 1, it saves a lot of time. 2, there is no human intervention. 3, we are not getting into the farm. Okay, so it's very fast, the job is done. Just you put a geofence, you are done it. Okay, and the disease control. Yes, it's all going good. Okay, what's the problem? Are we giving right pesticide? Okay, are we giving the right pesticide for the right pest? That's a big question. Are we having any data logging system to measure how much intense of the pest is there? Point number 1. And how different varieties of pests are there in the farm. See, whenever the pest comes, it's not only one variety of pest will come. Okay, there will be chance of 1 or 2 or 3 varieties comes. So are we really treating all the 3? And are we giving the right amount or right quantity of pesticide to the plant? Okay, that's a big question, right? And as I said, the farmer is spending a lot of money on the pest control alone, right? So that is where there's a company called TrapU. Okay, so they given a very beautiful technological solution. Okay, but unfortunately, it's not from India, right? And what they do, they have a small trap like this. Okay, a small trap. Okay, pheromone trap. Okay, simple. Okay, when we go to a mess or a canteen, we see a blue light, right? So what is the blue light? It attacks all the houseflies, no? So that's the light is basically a trap for the houseflies, right? Similarly, what we do, we give some kind of a chemical pheromones as well as the light-based pheromones to attract the pest into this box. So what we do in the box, we have a small camera, right? It's called a micro camera. What the micro camera does, it keep on capture images in it. So because the pheromone, the pests are being attracted, we keep on taking image. So in the long run, what we do, we understood it. Okay, so this pest is there, and the interest of the pest can be mapped with your projection in AI model. Okay, now I can able to say in this place, okay, this is the quantity or this is the intensity of the pest is running over here. So if I give this pesticide, it treats, okay, it actually directly kills that pest. This can able to happen. This can be only happen when you start counting the number of pests, right? Because that's the intensity of the pest, right? So are we doing it today? No. So what we are doing it today, some cases, pretty good cash crops, an agronomist will come, he inspected and then he suggested it. But still, he also comes with an assumption based and the sampling based quantity, right? The moment we keep this setup, we can able to quantify it. Okay. And the true fact, because of the pest and the disease alone, $220 billion worth full of food is getting wasted every year. Okay, I'm speaking about only the pre-harvest. Okay, good. So the pest can be solved with the help of the traps to log the data about the pest, and eventually what this data help us to make a better decision. Of course, you all know that, okay, data is basically gives you to think and take a better decision in the future, correct? Okay, good. So that's about the pest and disease control. Okay, the next is the nutrition management, right? So plant takes nutrition from the soil, so we need to give a supplement to it. Okay, so we give it. Then the water management. So as I said, the plant grows, you're supposed to give right amount of water with respect to the evapotranspiration value. Okay, so if you are really interested in an irrigation, okay, of course, if you are aware of it, if you're not, please go and read about ET value. It's very interesting topic. Okay, so you'll be really amazed. Oh, okay, how can we think? Okay, how can people can think of this? Okay, so it's a very interesting topic, right? And the climate factor, that is, it's basically it's not in our hand, right? So that's a problem. So how can we solve this climate problem is a big challenge. Okay, so that's the reason people come up with the indoor farming. Okay, so okay, what's the problem with the climate? A sudden change basically affects it. Okay, a wind, so much of sunlight basically gives so much stress in the plant, and eventually it's become weaker, right? So in fact, in every aspect, the climate is actually affecting, and the climate change is actually inducing pesticides. It's inducing disease. It's inducing the nutritional deficiency to the plant, right? And eventually, look at the only one factor. It's affecting everything in the pre-harvest. So what people are doing, we come up with the hydroponics within the shed. Okay, we come up with the greenhouse. We come up with the poly house, okay, where we control the humidity, air quality, and we control the temperature in the shed, where we can able to grow better. Okay, like you have seen mushroom shed, right? So what they do in the mushroom shed, because mushroom need the right temperature at the right stages. So what they do, they had a proper control system to do it. But in the olden days, it was growing in just like in the random places. But now things has become more regulated, correct? Okay, and you would have seen people are growing saffron in indoor. Okay, and that become a very good business. Even people are doing the same thing. See, saffron is growing in UAE. Can you imagine? Okay, see, basically we know saffron grows only in Kashmir, right? But now saffron is growing in UAE. But where? In the indoor shed. And what is the challenge in the indoor shed? We're gonna put power, energy. So where you get the energy from? That's a challenge. And what are the advantage in the indoor? No pesticide. Disease control become very, very easy, and no other external disturbance is not there, and we can able to monitor it, and we can able to monitor the plants very effectively. So put all together, the indoor farming is very good, but at what cost is the question? Yes, okay, good. Once all these things are done, let's assume, like, we start from the soil preparation to this still part. With all the tech intervention, we filled it. Okay, but if you miss to harvest at the right time, everything is gone. Okay, I hope you are connecting all the point in the pre-harvest, right? So start from the soil preparation. If I miss any of the one step, okay, my output is going to drastically affect it. Okay, just only in the pre-harvest. So keep this in mind. Put all together. It's all one line. If somewhere one crack happened, I'm going to get a drastic loss in my production. Okay, that is the biggest worry of a farmer. And look at the whole things happen with the farmer and who's not educated, but is intelligent to take a right decision. But they are very reluctant to take an advice, right? So that's the typical scenario in Indian agriculture system now, right? So now the challenge is, can we give dedicated technology at every stage to the farmer, and is he ready to afford it? It's a challenge. So eventually what happened? It become service-based solution, right? Like for an example, take a tractor. Okay, I'll just give you a very basic example of how the business case happen in the villages. Okay, see, tractor is basically 6 to 8 lakh rupee cost. Okay, not every farmer is ready to buy a tractor, and even if you buy it, you're supposed to be skilled enough to deal with the tractor. You're supposed to be a good driver. You know how to deal with the tractor, and it's not, the skill is not with everyone, right? So one fellow from the village, he bought the tractor, eventually started giving this tractor as a service to everyone. That's one of the beautiful business model that what we built in India. Correct? in the same, okay, that's one proven model, right? So now whatever the like, let's take a paddy harvester, right? So we have seen a lot of things in the road, right? The big paddy harvester in India. So now there's a lot of paddy harvester you can see in and around it, and no one is buying it. Again, that becomes a service. So what I strongly believe, okay, out of my understanding, any mechanization or any technology will come into Indian agriculture will come in the aspect of service model. But the challenge over here is we cannot give everything as a service model. Okay, that's a big trade-off between these two to pick right one. Okay, so if you look at the pre-harvest, put all together, every state is very important. We cannot miss not even one state here, means one step. Okay, are we having a good technology? We are trying to build it. Okay, we need a young minds like you. We need a well-experienced fellows like you to add more value to this ecosystem, so that in the future, at least to our kids and then to our next generation, we'll give some food. That's one. Is especially look at, okay, we discuss only in the pre-harvest. Okay, now we'll give you one small statistics. Okay, in India, almost 25 to 30% of the crops is wasted in the pre-harvest stage itself. Okay, keep this in mind. 25 to 30% of the crops are getting wasted because of all the points. Okay, it's cumulatively it happened. Okay. How to reduce this wastage? With only technology. As I said, each and every stage you are in tech, and there's a big scope. Okay, is it all the technology has been matured in Indian agriculture? No. I'll tell you one most surprising stat. Okay, India has adopted only 1% technology. What about the remaining 19%? Still is vacant. Still there's a more scope is there. And why people are not addressing? Because there's a more challenge. Yes, right? Okay, so that's the story of pre-harvest. Okay, so the day I identified the crop is mature to harvest, yes, now we go for harvesting. Okay, for harvesting, okay, just again, I'm taking mango as a small example, but the same is applicable to all the crop. Just think of it, okay? If you are not harvesting mango properly, look at the loss, how much is going to happen, okay? India is the world's largest mango producer, and in fact, India is the world's mango producing leader. Means we produce 55% of the world's mango. And you know how much we waste? Yeah, we were the top in wastage also. Yes, we waste 4.2 million tons of mango. But if you look at in terms of mango export, we are at very bad state. Why? We export less than 1% of that what we produce it. Okay. We waste more. We are very bad at export, and we produce a top. Look at see all these three are in three different extremes. Okay, so why? What's happening? And because of this loss, 2,000 crore rupee of worthful of mango is getting wasted every year, and it's a huge loss for a country. Correct. And I'll tell you one more surprising fact here. Take Thailand, okay, or take a Mexico. They are like top in mango export. You know how much they produce? Half of that what we waste here. Look at the sad situation. Okay, so what we waste, their production is less than half of our wastage, but they're very good at export. Now the question is why? Correct? First point, whatever the steps that we are telling the pre-harvest, no, in the mango, we are not intently following it. Point number one. And the main reason is excess pesticide, excess fertilizer, and this to eventually add more residues in the mango. This residues in the mango eventually getting rejected from the export industry. That's one problem number one. Okay. Two, we don't have a proper quality assessment techniques for a mango so that we can able to export right mango. See, when you go for an export, people are ready to pay excess money. What does it mean? We should give a right quality product to them. Are we giving it? Are we have right technology to do a quality assessment? No, we don't have it. Okay. Is it the only problem? Are we doing a right way of harvesting it? That's a big challenge. Okay. Look at this now. Okay. Though mangoes are produced successfully in India, 30% of the mangoes wasted in post-harvest. Please do remember, the pre-harvest is 25 to 30%. That is different story. Okay. And the post-harvest is something different. Why? This is the story of after picking the mango from the tree. You're getting it, right? So now you're supposed to cumulatively look at how much we wasted. It's mind-blowing number. And why? It's all just lack of technology. From where? Everywhere. Okay, yes, good. Let's get into the post-harvest now, okay? Now, out of our research, okay, because we did intentionally for Indian mango, okay, out of our research, what we identified is, out of this 30% mango, 20% mango is actually wasted just because of the sap injury. Okay, what is sap injury? You get a mango milk. Okay, when you harvest mango, you get a mango milk. Okay, so mango milk is basically an acid. This acid burns the mango skin. When you burn the mango skin, that spots become pretty weak, and that is the right way to enter all the disease into it. One, and that's the place where the spoiling started early. So if we have a better technological solution, a better practice at least in the farm to avoid the sap, eventually can able to save 20% of the mango. But why we are not doing it? First point is lack of awareness. Two, a lack of technology to do this process. And eventually how it's affecting. Okay, look at this number. Okay, look at the reason. Okay, poor harvesting and rough handling, inefficient desaping technique at the farms, unavailability of skilled labor, and unstandardized grading system at a farm. Okay, look at all the 4 parameters eventually pointing to the post-harvest loss. And where it's all starting? In the farm itself. Correct. Okay, let's say you go to mango. Let's say you go to a shop, you pick a mango. One mango looks very good in yellow color. Like the other mango looks a lot of black spots. Which one you pick? As per the human psychology, we always pick the right mango. If you really look at inside the mango, maybe this black spotted mango may give you a better taste. But because of the human psychology, we always pick the good looking mango, right? Okay. Okay, keep that apart. These 4 parameters highly affecting the 30% loss in the mango. It's a very big in number, right? If we solve this problem, okay, just the sap problem alone, you know what happens? Okay, look at simple. Okay, so let's take a life of a mango. Okay, I go to farm today, I pick the mango from the tree. Now what happens? Clock started ticking, means the life of mango. Okay, 10 days. In the 10 days, within 10 days, you should do all these things and then you should consume it. If it's not, you go beyond 10 days, you know what happens? Mango spoiled. Now, look at in terms of the processing, 5 days it is in the process itself. So how much time the mango is there in the market? Only 5 days. And is it the process very efficient? No. Every process over there in the 5-day process is delayed. Why? Because mango is harvested somewhere and it is processed somewhere else. Within this time, the enough effect has been done. This is a problem. Okay. So what if we come up with the farm level solution? Okay. Let's say we come up with the post-harvest handling at the farm level itself. Okay. So where we can able to pipeline the process, now we can able to push this mango to the market within 3 days. Now what happened? Plus 2 more days, means 7 days mango is there in the market, where it is there in the display. The wastage has been reduced and people can able to pick mangoes. So put all together, now by doing this desapping at the farm, 10-day mango become 12 days now. Mango can go for 2 more excess day because there's no path to enter the pathogens, right? So now what happened? Mango still looks fresh. So 12 days, out of this 12 days, we extend the shelf life of the mango by doing this for farm level handling setup. Okay, 1, we extend the shelf life. 2, we reduce the wastage. Okay. 3, we saved a time for the processing setups where they can able to process more number of mangoes. Okay. Now, it's about the post-harvest. Okay. Now, the post-harvest is actually directly proportional to your harvesting timing. Okay. The way you harvested, the technique you do to harvest, and are you harvested the crop at the right maturity is a big question mark. Okay. In order to pick right harvesting, you're supposed to be highly skilled. Okay. If it is not highly skilled, we should have a pretty good technology to assess for the right maturity, right? Are we having it? We are trying to develop it, right? Okay. So now look at just a small intervention in the post-harvest, okay, while harvesting, how it's impacting the whole journey of the post-harvest. Okay, can you correlate it now, right? Okay, I hope. Yes. Okay. So now look at, before it comes to the consumer, okay, a grower, the farmer, he gives all the possible stuffs. Okay, start from the light, temperature, humidity, growing media, fertigation, variety, okay, canopy management. Okay, see, basically very simple, right? So now you cannot leave tree just like that. Okay, you're supposed to maintain the tree. You're supposed to go for a pruning very regularly, especially with the fruit plants. Okay, the fruit trees, you should go for pruning. Now the question is there any proper way to prune it? Is there any standard to prune it? We don't know how the standard operating procedure. Okay, people are trying to build now. Okay, so now that's what I mean. Okay, what are the problem that I'm pointing it? There are a lot of people who are trying to solve this problem in different segments, right? Okay, and the crop production, okay, harvesting index. When should I go for harvest, right? And the protected cultivation, mulching, bagging, everything will be done in the farmer side. Once it is done, once we harvest it, okay, harvesting method is very important. Then grading, sorting, as I said, if you are not doing a proper grading and sorting, eventually that also affects the more wastage at the end. Okay. And what's the problem in Indian agriculture? As I said, the small scale farmers, okay, where a farmer cannot convert that product into a value added product. Okay, farmer can able to sell a tomato as a tomato, because I own just 2.5 acre farm. I produce like, hardly 200 kg of tomato per day. If I put a smart, let's say, tomato sauce making setup in my farm, I cannot make a return of investment. Why? Because my production is less. Okay, we need to go for a mass production like Western country. See, on average, land owned by a Western farmer is 250 acre. India is like 2.5 acre. Okay, 100-fold less. And look at, I'll tell you one more status here. To produce 100 unit of a grain or 100 unit of some produce, 5 people are working in Western country. In India, 110 people are working. And why the gap, the huge gap in the same 100 unit quantity is just because of the diversified in the farmland. Okay, very small chunk land owned what we have it. Okay, that's one of the primary challenge what we have it. Okay, let's say you harvested the mango or you harvested any crop, we do something called a pre-cooling. Okay, maybe if you are into agriculture, okay, you after you harvest the paddy, okay, we put in the big plain surface to dry it out. Okay, or you take any crop, we do a process called pre-cooling. Okay, the pre-cooling take your crop from their temperature to the ambient temperature. Correct? Let's say in the post harvest we did everything and then we got a pretty good, after sorting everything, we got a pretty good produce. And are we going to sell the produce? No, we convert that into value added products or we store it for the future. So what we need for the storing is a cold chain. Is it really a cold chain is necessary for every crop? It's a big question mark, right? So for an onion, okay, trust me, the cold chain is not an ideal solution. Okay, so for onion, then what to do? So people have come up with a very optimal, beautiful solution. Okay, there's a startup called sorry, Godam Innovations. Okay, she's basically okay. The story of Godam Innovations, like Kalyani Shinde is a founder. She's basically a farmer's daughter. Okay, and she keep on from the childhood. She was keep on looking at the lot of. She's from basically Maharashtra. Maharashtra is very good at big onion production. Okay, and she was keep on seeing a lot of onions getting wasted. And look at the sad story in any agriculture product. When the produce is more, the cost of the produce is very low. When the produce is less, the cost of produce is very high. See, look at how pathetic situation it is. So she, being an engineer, okay, she come up with a beautiful solution. Okay, we can able to store an onion. Okay, we can able to store an onion without a cold storage. And that is exactly that what you're seeing in the storage, right? And they store like this because onion need to be breathed out. Okay, it's supposed to give a lot of ethylene gas. The ethylene gas is supposed to be taken out. So what they do in this setup, okay, they just store it with the proper ventilation. Whenever they just close it, whenever they any excess like wind or rain is coming, they just close the shutter. Whenever they had a sensors, IoT sensors to measure the gas coming out of the rotten onion, okay, the rotten onion, that they sense it out. Whenever they find it out, then they suggest to farmer, it is right time for you to pull your onion to the market. Look at now, whenever I produce more onion, the cost of the onion in the market is very low. With the help of a tech, just by smell sensors, okay, with the proper storage technique, I can able to make a pretty good amount of money. And look at the cost of construction of the shed. It's very less. It's very less because there is not high tech fundas, like it's not there in it. Okay, just a small modification in the storage technique, and they had a proper sensors, and they give a right intimation to the farmer. Beautiful solution, right? And I suppose still one more thing. Okay, out of our primary research, when we discussed with a lot of stakeholders in the agriculture, okay, what we understood it, a farmer need a more affordable, a more easy solution. Okay, we should not make them more complex, right? So that is what one what do you call observation or identified what we got from the farmer. Okay, or an insight. Okay, so look at the costs of total food loss during the post-harvest chain alone. Okay, see, harvest is one proper thing supposed to happen. It. Let's assume harvesting also properly done. Okay, now what happened? First thing, post-harvest also we had a problem of pest. Right? We have a problem of rodent, rat. It's the biggest killer. Okay, in any plant, in agriculture farm, rat is the biggest killer. Yes. Okay. Is there any right technology to solve this rat problem? Till today, no. Till today, no problem. No solutions available. Okay. One. So even if you come up with a solution, okay, how you identified? Okay, yeah, that's that. I'm just leaving that as an open thread. Okay. So you find out, is there any possible way can you solve this rodent problem? Okay. One. Two. When you come to the storage, okay, before getting into storage, we supposed to do a proper grading. Are we having a technology to do a proper grading? Again, grading comes out of different scenarios. Okay, one, just by appearance based or internal quality based. We need both actually. Are we having it? No. And whenever you go for a storage, the storage also need a right ambient to store it. Right? Are we having a proper control system to maintain that right ambient temperature with the proper control system? There's a big scope to work on it. Why I'm telling big scope? Because for every crop, the requirement of storage condition is something different, right? So that's very important. Okay, for example, I show an onion, right? The story of onion is something different than with an apple, than with a mango, right? Or than with any other fruits and vegetables, right? One. And proper humidity. Let's say you're not maintaining a proper humidity. What happened? The fruit's weight is started losing it. You're getting it. So when the fruit weight is losing, eventually you are touching your stomach. Okay, why? Because the weight is what at last the cost is. Correct. So you're supposed to have a pretty good humidity maintenance supposed to happen, right? So that control system. Okay, is there anyone who is doing this whole storage control systems? Yes, there's a company called Impens. Okay, they are from IIT Madras Research Park. Okay, the founder is Dinesh. So what he's doing? Okay, he come up with a farm level solution. Sorry, I'm extremely sorry. Okay, cold storage level solution or a storage warehouse level solution where they can able to give us sensors similar like the Godam innovations, but this for the cold storage. For again, for different fruit, they give a different breathing pattern. Okay, so what they do, they keep monitor it. Whenever they identified excess ethylene or excess other rodent gas in the cold storage, they suggested it, and then they try to suck the air out from the cold storage, right? So eventually this increase the spoilage. Okay, this basically increase the part of this basically reduce the spoilage rate because of one. Okay, very simple. Okay, if one onion is spoiled, what this will eventually does, it starts spoiling nearby fellow. Then it become like avalanche effect. Okay, I hope you know what's avalanche effect. One small stone can become big avalanche, right? So that same thing. One onion, if this spoiled all the nearby 5-10 onions. When this 5-10 onions is spoiled, this spoils another 100. This 100 become 1000. Eventually done, right? So this Impens, they had a proper cold chain solutions. Okay, especially to maintain the ambient for the cold storage, right? Okay, so that's one, right? And as I said before, processing, you're supposed to go for a proper sorting, and the sorting need a tech. and then depends on the weight, grade, appearance, put all the parameters, and this need a dedicated solution for every crop. Okay, I cannot use what are the sorting algorithm I built for the mango, I cannot use it for guava. Correct? So because mango, the data set what I have collected is for only for mango. And look at the mango. Mango, we have somewhere around 1,000 different varieties in India. Out of that, 30 different commercial varieties are there. All 30 variety need a dedicated setup. Means at least in terms of data. Okay. Now the question is, are we having a data? The biggest $1 billion question today. Or is there a big data available for Indian agriculture to make a right decision? As per our exposure, okay, as per our understanding, as per our search, no. We are trying to do it now. Okay, a lot of companies, they just only do data collection. They do only data collection. And they get a lot of money out of this. And why this data collection is very important? Because that is the base for, again, see, let's say you build an AI system. Okay, AI is basically a kid. You want to train the kid. How you will train? You're supposed to give a good data to train the kid. No. What if you give a bad data? Then the AI become very bad, right? So good AI comes out of good data. Are we having good data? A big question. Collected. Is there any platform to collect the data? A lot of people are trying it out, but still not even 1% is filled. Okay. We have 100% to fill it. Lot of scope is there just to only on the data collection part in Indian agriculture. And do remember, World Bank has actually pointed it. If you claim that you are an agri-tech company, you should collect data. If you're not collecting data, you cannot claim yourself as an agri-tech company. So look at how important the data is, I mean. Right? Okay, good. And okay, that's about the storage problem. Now look, come to the processing. Okay. Right? Sorting should happen. Okay. Throw away all the bad stuff from it. Okay. Proper inspection should happen. Right? And that's the processing. Okay. For this, again, we need technology. For example, okay, I hope you would have seen this in the rice bag. Okay. Sortex. Okay. Sortex. Okay. Sortex is actually a technology to throw away all the black spot. Okay. Black rice from the white rice. Okay. So maybe they had one big conveyor belt. Okay. What they do, they had an UV lights, leaf spray. Okay. Will become from the down. And they had a proper tech. Okay. They are imaging to segregate all the black rices. Okay, so you have seen a lot of grading machines in a lot of videos, right? So that's that, right? Okay, now come to the packing. See, we did very good pre-harvesting. We did very proper way of harvesting. We just stored it properly, and we just processed it properly. If we fail to do packing properly, whatever we done from the day one to till today is waste. Okay. So now I just want to introduce you one more company, okay, and they have very well proven, okay, and okay, what this company do is, okay, they are a small sachet, okay, and okay, I hope you guys know about a company called Greenpod Labs, okay, they are a crop science company. So what they are doing, okay, they come with a small sachet. They have a small sachet. Okay, let me show a solution to that. Okay, what they use, they have a small sachet. That sachet is basically speak with the harvested vegetables or the fruits. Okay, basically they work on different crops now. Okay, they're also pretty early stage startup. Okay, what they're doing is they are trying to build a sachet. The sachet basically put in the package for the vegetables and the fruits. This sachet helps the fruits to survive for a longer time, right? So one, and is it the only problem? This can extend the shelf life, but right packing is also very important. Correct. And let's take for an example. Okay, you take a mango. Okay, mango skins is very delicate. Okay, you cannot randomly dump mango in a big box. Okay, mango supposed to be there, only 2 or 3 layers should be only stacked. Okay, you cannot stack more than that. When it is ripened, then you lost everything. Okay, so right packing is also very important. Okay, and is there any standards to pack all the agriculture produce in India right now? People are coming with the different standards now. Okay, once packing is done, then only things are in good state. Okay, now the next part is the business part. Okay, I packed mango very well, but I don't know how to market the mango to the people. Oh, that is a big challenge. Correct? Okay, that's the business part. Okay, so and like and then we just put this produce to the what do you call the display in the supermarket. Now this goes to the, let's say I go to we go to the supermarket, we buy and then we eat it. Okay, and look at in terms of wastage. Okay, as I said, the post harvest is 30%, the pre harvest is 30%. Okay, so now look at in this post harvest loss. Okay, where we are wasting more in the all these 6 stages? Everywhere, including in the consumption. Okay, we waste a lot of food in the plate, right? Okay, one. But look at the beauty part here. Okay, beauty part of India when compared with the Western countries. Okay, India, we waste very less in the table. Okay, we waste too much in the farm. Okay, the pre-harvest loss. Okay, in the Western countries, it's exactly vice versa. Okay, because they had proper technologies, they waste very less in the pre-harvest, but they waste a lot of food in the table. Okay, that's our culture, right? Because since our childhood, they people are saying don't waste food. Okay, and that become a proper mantra for us. It's keep on running in the mind, right? So, but it's not the case with maybe the Western countries, right? So that's the challenge, right? So now we just try to cover, okay, pre-harvest, harvest, and the post-harvest. If you really want to get a very good produce at the end, where you should start from the right soil preparation, and each and every step needed technological intervention. And how much technological intervention we have till today in India? Just only 1%. How much gap is there? 19%. And for whom this 19%? For the researchers, for the students, for the farmer community itself, right? And this is big space. Like, see, 50% we need population in agriculture. Only 1% technology has been adopted. Look at how big gap is there. Look at how big opportunities there for us. Correct? Yes. Okay. So I hope now you have understood it, right? So how we can able to put technology in Indian agriculture, okay, and how people are adopting currently now, okay, and how can we accelerate the phase of our adaptation, right? So that's the ultimate goal, okay. And look at the innovation map in agri-tech, okay. Again, a lot of companies, okay, not only in India, not only in the Western country, around the globe, okay. Take China, they are like marvelous in agriculture today, okay. Start from water conservation to the processing, they are very good, okay. And they say 50% of the world's food grains are stored in China, it seems, okay. Because if they can able to think, okay, if they think, they can able to put food scarcity in a world, it seems, okay. That's the level that they have attained it, okay. India is heading towards the same thing, okay. But the problem is the same, okay. The data is too much of lack in India, okay, but it's not the case in China, okay. If you ask me personally, what the first point should you focus? First, start collecting the right amount of data for Indian agriculture, okay. If you start doing this, then that's a marvelous breakthrough is going to happen in India. Like how digital India transform Indian consumer ecosystem, start from mobile phone to the UPI. Okay, similarly, if you start collecting data in agriculture, that is a marvelous piece which will transform the Indian agriculture, and we will become top in the globe, especially in terms of agriculture. And do remember, all the big companies, including Bill Gates, has invested a lot of money in agriculture. Okay, you take a Geo. Okay, Geo has come up with Geo Crop. Okay, Geo Kisan. Okay, what they do? They come up with IoT solution for the farms. Wow. Okay, why Geo? Geo deals with petrol. Why should they come up with an agriculture? Because that is the big thing in the future, right? Okay, and look at what are things is giving leverage to the Indian agriculture, IoT. Okay, as we discussed all the sensor parts, right? The smart farming, right amount of water, right amount of techniques, right amount of fertilizer we're giving it, and the precision farming where we cover with the drones, where we take images from the satellites. We clearly mention which crops are getting stressed, where we can able to give excess fertilizer, which plant need to be treated well. And the robotics and automation, because the number of people who do agriculture is going down, so we need more automation towards it, right? So there's a company called Agrobot, they're doing it, as I said earlier, right? And now people come with the vertical farming. Why? Because the ambient become very what do you call, very difficult to grow a plant, right? So we come with the indoor planting it, okay. But it has its own cost, But eventually, but what's the advantage in the vertical farming or indoor farming? The yield is 3 times, 4 times high, right? So of course, there's always a trade-off, but it's happening, right? And look at a biotech. Okay, so how this biotech is enhancing? So we come up with the different we come up with the different sachets. Okay, for example, previously I showed green pod labs, right? So what they're doing it, they come up with the biotech based solution, the small sachet, which eventually extend the shelf life of a mango, right? And like we come up with the different fertilizers, okay, different formation of fertilizer from the natural stuffs and so on. On top of everything, okay, data is more important. Okay, are we having it? We don't have much. We need to collect it. Okay, so that is one of the big part for especially in Indian agriculture system, right? And the drones and satellites increasing more leverage, and the climate. Okay, what will happen tomorrow? It's going to rain or not? Should I go for irrigation today? Should I go for harvesting today? Everything will be done with all integrating all the tech together, right? Okay, so it's all good, right? We just covered all these things. Okay, pre, post, and the harvesting. And as a consumer, okay, what the people are thinking today, and especially the post-COVID, okay, people are become more health conscious and they want an organic food. Okay, the question is it organic? Okay, how do you prove that this is organic? Okay, now people started demanding something called traceability. The traceability is the biggest buzzword currently. Okay, not only in India, like around the globe. Okay, I want to know where my food has been cultivated. Okay, I want to know what are the pesticides or what are the amount of input has given to the plants. Okay, I just want to know because I'm the one who's going to eat that. Correct? Okay, simple. Then I just want to know when this has been harvested. I just want to know who has processed this food. Okay, or anything, rice or mango or whatever it is. Okay, and I am paying 100 rupee. Okay, how much money out of this 100 rupee? How much has been to farmer? Okay, how much have been to the harvester? So I need, because I'm ready to pay more money for the sake of eating a good food. Good food is good health, right? Safe, very straightforward equation, right? So good food is equal to good health. Eat a good food, you will be very healthy. The question is, are we eating good food? How will make sure that we are eating good food? We cannot cultivate it because we are in a very modern world. We run for our own work, right? So I should have some trust. Okay, who's going to give the trust? The traceability. Now the question is, the biggest question here, is the data that out of this traceability giving is correct or not? Okay, so how will make sure given the data is correct? Somewhere we should have a foolproof technique, a foolproof platform to store all the data, start from the farmer to the seller, right? That is where the blockchain is playing a very big key role in agriculture system. Okay, so trust me, the blockchain is going to revolutionize this agriculture industry with the help of data collection. Okay, so that no one can able to manipulate the data here, right? Of course, people are prone to do certain things in the other side also, right? So what blockchain will do? Blockchain is going to help to accumulate all the data, and the data is going to be a more reliable data and the more integrable data, right? So that's what exactly happened in agriculture now. Okay, so as we said, the IoT is giving a lot of information, and with that we can able to take a beautiful decision out of it. Okay, this decision is what exactly we needed today. See, simple. Okay, we take the story of tomato. If I have an idea of how much acre of tomato has been cultivated, I know what is my demand. Okay, I just know, I just don't know what is my production. If you know what is my production, I can able to always balance my production and demand, so that I can able to keep the cost equal around the year. And it's not happening because the collection of data is so much of lagged, right? So that is one big challenge, right? And this IoT is giving a lot of leverage in agriculture. Start from sensing, put the whole story that what we discussed. Each and every stage, IoT is playing a role, right? Okay. And what are a few use cases implemented with IoT, like monitoring it, okay, irrigation, that as we discussed it, and automation. Okay, now after looking at the livestock, okay, I just missed to show you one more company. Okay, it's an Stellapse, and Stellapse is a beautiful company where they had a software-based as well as an hardware-based solution, and they try to revolutionize the dairy supply chain. Okay, milk, right? So milk is a big business in India. Right? Again, India is one of the biggest milk producer too, right? Anything you take in agriculture, like in India, will be in at least in top 5 or at least in top 3. Majority crop will be in the top 1. Okay. But only thing is, later we are very bad at taking it forward, right? Take what they do. They had a small band to monitor the cow. Okay, they just know how good the cow health is. Okay, one, because see how we, like, when I'm not feeling good, I'll not walk much, right? So the same correlation that they do with it. Okay, did they collect the milk? Okay, come to collection center. They have a proper data collection setup to say, like, how much amount of milk has been collected in this region today, and what is the quality of the milk. Okay, so how much fat content, like, above 7 or not. Okay, we go with the lactometer to measure the density of the milk. Okay, so by measuring all the parameters at the instant, I'll get a bill and I'll get the quality of my milk, right? So the Labs has done this, right, too. And they had, like, each and every stage. Okay, from the collection center, go to the chilling center to the processing center to the packing to the distribution. Everywhere they had a beautiful data, and they are running the show for a longer time. And this because it's a unicorn company. Okay, now if, let's say, government want to take any decision on the supply chain, okay, or on the dairy product, okay, they should actually approach the Labs company. Why? Because they have a data. Simple, right? So that is one beautiful thing with the dairy. Okay, so I'll just show you one more company, right? So look at, there's a company called Fuzzle from Bangalore. Okay, it's an Indian company again, like, except this trap you, rest all the companies are Indian company. Okay, so what this Fuzzle is doing, they have an IoT based solution. They put in the form, and where, as a farmer, I'll have an app. Okay, I just get all the information about environment and all the basic parameters. I'll get it in the app. Okay, so and then what they can able to do out of this? Okay, again, it's a data driven, correct? And if you look at, okay, being a computer science teacher, okay, what I see as an IoT, the biggest ultimate goal of IoT is not on automation, because automation done long back. Okay, the biggest job of IoT is to collect data, right? So that's what exactly is doing it, right? And other use cases for agriculture, like, in the IoT, we are trying to do an automation, but automation is the last, right? Because automation is not a big thing, because people keep on doing it since so long, right? Okay, so look at the crop production was easy with IoT. Okay, and, like, harvesting prediction can able to happen, and we can able to, okay, IR based or heat sensor based night predator production. I told you the rat, right? Okay, rat. Yes, see, if you have a sugarcane field, okay, because I'm basically from a farming background, that's right. Okay, or if you have a paddy, especially sugarcane and the tapioca, okay, it's very big problem with this big rat. Okay, what's the big rat? Very sorry. Okay, I'm sorry, I don't know that. Okay, and as I said, like, how a tractor become a very good mechanical solution to the entire farming system. Similar, like, what are the agriculture technological solution should come like a solution based stuffs. Okay, and, like, lot of other sensors, like, poultry monitoring, like, cow monitoring. Okay, fish, like, fish culture monitoring, and it's keep on going on. Okay, it's keep on extending it, right? Okay, and things to consider on an IoT. Okay, one is the cost. Okay, especially here. Two, where we store the data, and, like, are we really secure? And the major thing in the IoT is the connectivity, because in the agriculture, right? So this is one of the key challenge, and people keep on working on it. Okay, so yes, a lot of people who work on, especially on IoT communication, right, or IoT networks, right? And of course, as I said earlier, data is a decision. Okay, there is no doubt in this. Better the amount of data I have, okay, I'll take better the decision. Right, so better the decision I have, okay, I'll have better the future. Simple. Okay, straightforward. So now, where you get from the data? From the data source from the soil to the end consumer. Okay, if I have all this, I know what is my consumption rate. I know how much I'm going to produce it. When I balance this, the country become very beautiful, right? Yeah. And smart tagging with an IoT. That's what is the blockchain based solution, right? So I need to track. Okay, I just have to give a proper traceability to the food, right? So starting from the production to the consumption. Okay, when I have the traceability, and when I have the proper monitoring, when I have proper feed to the plants, start from the soil to the consumption, then that is the proper agriculture, right? So that is where I can able to tell, right? So I can able to properly predict. So tomorrow I'll get 100 kg of tomato to the market. I can able to do it. But is it that much easy? No, it has one challenge, but eventually challenge is what the opportunity is all about, right? I strongly believe in that, right? Okay. So international trade, again, when we think of an export, it's become even more difficult. We have to really take care, start from the farm, right? And I'll tell you a small story here, right? Okay, let's say we export a mango to German. Okay, after, let's assume the mango reached the German airport. Okay, they do something called, okay, they had food agriculture officers. Okay, they inspect the mango. If it is not meeting their quality, you know what they do? They cannot resend this cargo because that's costly, and they not dump it in the dustbin. They burn it. You know who has to pay for the burning? We have to pay from here. That's the biggest challenge here, right? So agriculture is pretty. It's a very good, and it's very challenging. At the same time, it's very interesting. Okay, of course, where you will get interest, where there's a more challenge, right? Of course, yes. Okay, so that's about in the form, right? Okay, apart from this form, what is the tech is developing, right? So now, okay, before getting into it, okay, let me put one word here. Okay, I hope you guys have heard about a term called virtual water, right? So virtual water is something, for example, in order to produce 1 kg of rice, okay, I have spent 4,000 liters of water to produce 1 kg of rice. Okay, so it's called virtual water. Okay, so if I waste 1 kg of rice food, it's indirectly I'm wasting 4,000 liters of water. 4,000 liters of water. It's a big, right? Okay, that's a virtual water, right? Okay, so you know, if I want to grow a pig, if I want to get a pork, okay, I have to spend lakhs of liters of water just to get a kg of pork, right? So look at problem. But what are the advantage in the pork, or what are the advantage in the non-veg things? You get a pretty good protein, right? So can I able to get the protein without growing that? Yes, you can able to grow the protein in the lab, right? Okay, you can able to grow the protein from the plant-based extraction, right? So now look at the people are crazy enough to think in different aspect. Okay, they come with a beautiful lab-based meat. Okay, where they culture the meat. You know, some days one burger was costing you $10,000. Okay, now it become $15. The cultured meat. Okay, so because everything goes in a large scale, the cost drastically goes down, exponentially goes down, right? Yeah. So that's an advantage. One, right? So two, look at how we print. Okay, initially we were printing a paper. Now we started printing objects in the 3D prints. Okay, now people are printing human parts in the 3D print. So why can't we print food in 3D? Yes, it's possible. Okay, a lot of people, okay, they're working on how to print a food. Okay, it's pretty interesting. You know, I was when I heard it, I was very interesting. Wow, it looks like it's kind of a teleportation. You know, okay, I just felt like that. You know, at the day. So okay, now these things are happening. Okay, apart from this, where else agriculture has a bigger scope? Yes, no, take Elon Musk. Okay, he's planning to go to Mars. Okay, how will you feed people in the Mars? You have to grow, right? Okay, how will you grow, and what plant you will grow? And again, what's one more challenge here? You know, FAO come up with standards and says, okay, if an adult should take this much amount of vitamin A, B, C, D, nutrition, amino acids, the big list is there, right? So everything should be going to him. Okay, you cannot pack and take the food to Mars. Why? It's so costlier. Okay, it's actually better you produce in the Mars itself, right? The question is, how you give proteins to them? It's a big question mark. Correct. And either you have to grow chicken, or you have to grow any other poultry things, or cattle, right? The question is, where's the water? I told you, right? 1 kg of pork needs lakhs of water. Where's the lakhs of liters of water in Mars? We don't have it, right? So what to do? So we have to come up with a pretty good technological solutions to fill all the FAO standard food nutrition to the human being, right? So that is where the biggest scope is there, right? Okay, maybe like the movie Interstellar. Okay, maybe we have to find an interplanet. Okay, so maybe if that is the case, okay, just an assumption. Okay, we need a technology like that, right? And is it people are working on it? Yes, people are working on it. Elon Musk, there's one more subgroup. Okay, they especially work on BLSS. Okay, so note the point. BLSS. Okay, it's called Bio Regenerative Life Support System, and especially this BLSS is meant to grow food of the earth. Okay, let's say you grow food in the International Space Station, and you go grow food in the. Of course, it's not possible in the moon because there's no atmosphere. Maybe you can try that in Mars, right? So and people, they started doing research in food on the space. Okay, it's very amazing, right? Okay, and put all together. Okay, I think I'm a bit dragged more time. Okay, I just I'll conclude it. Okay, what's the need of the hour? Okay, we just need a sustainable innovations. Okay, a sustained innovation where we need to solve the real problem. We need to collect a lot of data. Okay, we supposed to have very efficient hardware and software integration with very low cost, especially in terms of Indian scenario. Okay, and we should have a mechanism, and we should have very good agriculture practice. Okay, and do remember this term gap. It's called a good agriculture practice. It's a standard. It's a gap certification, right? If you really want to look at developing a produce which where you can able to push this to global market, where you want to beat other countries like giants like a China or like Brazil, especially in the like what do you call it, strawberries or some fruits. Okay, so we should have the gap certification. Okay, are we having it, and how many number of people in India has a gap certificate? Very limited. Why? Because we don't follow the standards. There's no SOP for it, right? So that need to be get standardized, right? And the cross border acceptance. Okay, so somewhere like we should have a pretty good, it's in the government head. Okay, so they have to come with a very good policies to mutually understand, send and they receive the goods from them, right? And the legal framework. Okay, and there's a problem with the drone. Okay, you cannot fly a drone, right? So these kind of issues are coming, and like getting a satellite image with high resolution, it's very difficult in India today, right? So and eventually now the Indian government is trying to leverage, and then they're trying to take more startups into the space ecosystem, right? And it's happening, right? So put all together, okay? And of course, I just tried only the surface of the problem because it's a very big topic, right? And I didn't pick any one crop for the whole journey. Like I just want to, I don't want you to bias thought. Okay, I just try to cover. And some cases, I just took some example for post-harvest loss on the mango because so that you'll understand how much impact can happen just by harvest with affect the post-harvest, right? So put all together, okay? We just covered pre-post, so pre-harvest, harvest, and the post-harvest in the agriculture, and where the technology gap is there, okay? And how being a technical fellows, how can we add more value to this so that India become top in the fruit production? And India, because India population is very high, if anything happens in the food security, we'll be in the huge risk, okay? So India should really take right action and as soon as possible to safeguard our people in terms of security. And that is our ultimate aim of even our startup too, right? So we want to reduce the wastage. See, we don't want to do anything on top, okay? Reduce the wastage, that itself is a big thing, okay? And there's a professor, Dr. Mohan, okay, from TNAU, okay? He especially work on pest trap in the post-harvest grains, basically, okay? He's pretty interesting fellow. He said what word to me, okay? I become very big fan of that word, you know what's the word? He said, if I save a grain from a wastage, it's equal to producing the grain, okay? The moment he said, like, I was like wondered, wow, okay, why I didn't think in that aspect, okay? If I save a mango from the wastage, it's equal to I produce that mango. You're getting it, right? So first objective is reduce the wastage, okay? Come with the tech for reducing the wastage. Then we should focus on produce more on the pre-harvest side, right? So put all together, we'll be in the top on food security, okay? That's our ultimate goal, okay? That's one of vision of our company too, right? So with this, okay, I'm finishing my talk, okay? So let's go for discussion.
Thank you, sir. Thank you for the wonderful session and very thought-provoking. There are a few questions which were asked during the registration process, sir.
Yeah, man.
I'll just post by one, sir. First question.
Yeah, man.
How to get real-time data? Whatever research is going on in this domain, is it successfully implemented in the field?
No. If you ask me, no. Okay, because there's no data now. Okay, as I said, like there's a big gap in the data collection. Okay, and see, trust me. Okay, if I get a data, if you have enough data, okay, we become very smart. The challenge is we don't have a data, right? Somewhere we should have to build a frameworks to collect data. Okay, for an example, okay, for the mango, in order to grading the mango, we have collected 1.5 years of data. 1.5 years, okay, we collected data, means mango data has been recorded in one season, okay? It's not just only recording, you need to label the data. The biggest challenge lies on labeling it. It's like high human effort thing, okay? And that's one challenge, right? And two, sorry. And the two, implementing that data is not sufficient, okay? We don't have sufficient data to do it, okay? So it's just not implementing it. But eventually it start happening it, okay? So that's what I can able to tell you, ma'am.
Thank you, sir. Next question. Will technology able to circulate all over India, or it will be limited in some places only, like in Punjab, they use modern technology,
Mhm.
but on other hand, Bihar, they don't have good technology for agricultural work.
Beautiful, beautiful question. Yes. Okay. So that's the exact, the story of the whole talk, So adopting the technology is a mental model. Okay. It's called people's mental model. Okay. It's very difficult to change a mental model. But what the other side, as the advantage I'm saying, lot of youngsters are getting into agriculture now. Okay. And all the youngsters are very keen about the technology because they know how it can able to impact it. And you take even Bihar, okay, because very good in what's that red color fruit? Lychee, right? Yeah, lychee. But what's the problem? They do a lot of wastage. Now there's a group of youngsters, they come up with how to convert that value added product. Okay, it's happening, but it not happen in a day. It takes time, and because the crowd is so big, it's very difficult. But the adaptation started happening. That's what we are seeing it. Yes, ma'am.
Thank you, sir.
Yeah.
Next question. It's like, will adoption of AI and technology in agricultural sector cause job loss, especially in India?
Okay, that's a very good question. No, okay. So, okay, what I see, okay, being a farmer, okay, my father, my grandfather, everyone was in the farming. Okay, so it's not a job loss. Okay, agriculture, we are need of labor. Okay, we are not getting labor in the farm today, right? Okay, I'll give you a basic example. Okay, when I was a kid, okay, when I was like third or fourth standard, fifth standard, okay, we give 5 rupee to climb up a coconut tree, pick a coconut, come down to the climber. Okay, today we are paying them 50 to 60 rupee, but still we are not getting people. I'll tell you why. What's the problem? Okay, it's basically a generation. Okay, so the tree climbing is basically a skill. Okay, it has been passed from generation to generation. Now this has been breaked. Okay, now there's no people, right? So we need a mechanization to solve this problem. Okay, so especially technological intervention in agriculture will not make a job loss. Okay, that's my belief, especially in agriculture. Okay, but maybe in other field, yes, it may happen, but in agriculture, AI will not make a job loss. Okay, it's my perspective. I mean,
Thank you, sir. That's true also. And next question, sir.
yes.
With global warming affecting weather changes, how can we leverage AI to help avoid the effects of global warming to crops, both
Okay.
pre-harvesting and post-harvesting?
Okay, good. Very beautiful question. Okay, see, very simple. Okay, global warming is what we don't know when it's going to rain. We don't know when the temperature is going to up. We don't know when the temperature is going down. And somewhere we should have a better, robust prediction model on the climate. If we have that with the proper past, all the statistics data, we can able to solve this problem. Okay, so simple. Okay, okay. So let's say for an example. Okay, if I had have predicted, okay, I told you the story of mango in the post Shivratri in this season, it extended. No, okay. Let's say if I had have predicted this, the snowfall, no, not the snowfall. I'm sorry, the mist has been extended. Okay, what I do, I start putting sulfur down to the plant. What sulfur does? Okay, sulfur can able to give heat to the tree, so that I can able to sort out that loss. Okay, but we couldn't predicted it. Why? Because it's become more. It's not in the pattern now. Okay, previously it was in the pattern. Okay, now the pattern has been broken. Okay, so that is the problem. Okay, so but yes, AI.
Future aspect of research in agricultural systems?
Yes. Okay, that's what I told you since that I
Yeah,
started. You had a lot of scope. Okay, I just covered all the scope as per my knowledge, but it's not the only thing. Okay, maybe I'm a very small fellow. Okay, maybe there are a lot of people who do very intense research on it. Okay, so maybe things there are very lot of things to explore in this. Right? Yeah.
and this is a question which is very generic. Most of the faculties are from agricultural background, where the government gives some time management for the employees to continue agriculture.
Mhm.
Before 20 years, teachers given importance to agricultural and then they came to school. But now the working condition of engineering colleges are not like that. All
Mhm.
are following the corporate timing. Any
Mhm.
solution to cover, encourage faculty to do agriculture?
Uh, I don't know what to tell for this. Okay, ma'am, it's very simple. Okay, so when we become health conscious, okay, we start growing our food. Simple. Okay, and in fact, I'm seeing a lot of people. They're very keenly focusing on getting a good milk only for consumption, and when we start becoming health conscious, things will go back to the olden day. I believe in this.
That's true, sir. That's all the questions.
I
Anybody?
think
There's a
one more question is
one
there in the chat box, ma'am.
more-
Last now.
yes. So
That is, one second.
Chat box.
Yeah, how to leaf disease detection, identification, prevention in machine learning techniques, AI.
okay, so Tirumurugan, it's a good question. Yeah, simple. Again, first thing, data collection. Anything you ask, I'll come to the same point. Okay. See, again, like, okay, I'll give you one more thing. Okay. There's a company called Plantix, okay, Plantix. Okay. So, what the Plantix does, they have collected, see, they started the job in 2015. Okay. They have been keep on collecting data for a longer time. Okay. They collected it and they become very good company now. And it has been acquired by an European company. Okay. They become a $1 million company now. Okay, and what they sold to them is just only data, a model, right? That's what I'm telling you. Data is the biggest thing that what we need to collect it now, especially in India. Okay, and you take a Mahendra, okay, Mahendra Oja, okay, OJ something, right? They come up with a new mechanical setups, okay, to collect data and to help farmers, right? So now look at all the corporate companies are coming to collect data. Okay, you keenly observe it. Geo come with the Geo Kisan. The ultimate goal is to collect data here, right? So whatever you ask me, I'll come to one point. You start collecting data.
Thank you, sir.
Thank you, sir.
Anyone in the participants you want to ask any questions to the speaker, you can unmute yourself and ask. Senthil Pandian sir, do you have any questions? Please ask. Sir, if you have questions, please ask, sir.
We are not hearing. Not able to hear you properly.
So, I think there is no.
Yes.
Yes, sir.
I think he has unmuted and.
Okay.
Okay, let us proceed.
Thank you all. Now I request, sir, kindly mute your.
Yeah, thank you, Dr. Shanmugakumar. Really very interesting presentation.
I request our chair, Mythili Prakash ma'am, to propose the formal vote of thanks. Ma'am, kindly unmute yourself, ma'am.
Okay. Is Dr. Shanmugam is there in that chat?
Yeah, that's what I'm searching. He just left.
Yeah, he just he left, I think. Okay. Really, our sincere thanks to Dr. Shanmugakumar. A very amazing presentation. Yes, thanks for your valuable time spending with us to explain right from the soil preparation to crop maturity assessment and right from farmer to consumer, farmer to customer, production to consumption, that we are almost in the live experience of agriculture. Really amazing, sir. Thank you so much for your time and making is a very detailed explanation. So whoever, even we are not into farmer experience, Today we got it. So much. How much is that? We are just eating the rice. Behind that, how much is their efforts are there and how to take it, and also the detailed explanation about this blockchain, how blockchain helps them to for data collections, and IoT, how help to overcome this losses and speeding up the process and everything. Thanks a lot. A very detailed presentation. Thank you so much for your time with us.
Thank you.
Then my sincere thanks to our joint societies, ACM and IEEE CS, and also, of course, the audience, and for your questions, which makes further more elaboration on the topic. That is also very nice.
Thank
Thanks
you.
to everyone. As usual, our special thanks to Mr. H.R. Mohan to make this event for us to know about agriculture related issues and success. Thank you so much, sir. Thanks, everyone.
Thank you everyone for listening to me. Okay, I hope I didn't bore you guys. Okay, and
No, sir. Very, that is what you say. I hope your students will be very alert in your class.
yeah, I try to make them. Yeah.
Yeah. Very nice.
Yes. Okay.
Thank
Thank you.
Thank
Thank
you.
you, Mohan
Thank
sir.
you.
Mohan sir,
Thank you
thank you
so
so
much.
much for giving the opportunity. Okay, it's my pleasure to enlighten people what we know. So I'm happy.
Yeah, we'll keep disturbing you for a few more
Sure,
programs.
I'm very happy to get disturbed from by you. Means.
Thanks
Okay.
a lot, Dr. Shanmugam. It was
Thank you.
very,
you.
very, very, very informative, and more points, more this thing. So we can experiment more on it.
Super. Ma'am.
Yeah.
Thank you.
Thank
And
you.
also
Thank you.
explained in the layman terms, sir. So it was very easy for us to understand.
Beautiful. Beautiful. Super. Okay, ma'am.
Thank
So,
you.
Thank you.
thank you
and good night.
everyone. Have a great day. Bye bye.
Bye, sir.
Bye, ma'am.